All right, we continue with non-calculator multiple choice problems. We have three of them. And the first one is the integral of arctan. And this is going to be an integration by parts problem. I always say that if you see how to differentiate a function, but you have no idea how to integrate a function, that means you need to do parts where you're multiplying by a dv of 1, which is easy to integrate to x. And you do know how to differentiate arctan because that differentiates to du equals 1 over 1 plus x squared dx. So when I do uv, I get x times the arctan of x, that's here, minus the integral of v du, so x over 1 plus x squared. This section here, the integral, becomes a u sub problem with your u equal to x and, with your u equal to what's in the denominator, u equals 1 plus x squared, and du equals 2x dx. And you don't need the 2, you just have a single x over here. So we're going to actually divide by 2 on both sides. So I end up with a 1/2 out in front, and that's what I've done right here. I put a 1/2 out in front and then 1 over u du. And 1 over u integrates to the natural log of the absolute value of u. I went ahead and subbed in the 1 plus x squared from my u substitution. That's coming right back in there. And then, of course, you carry down the x arctan of x, which I put in with that arrow, but really because I'm just matching to the answer, I just did the arrow to save a moment of time. So I have x arctan of x minus 1/2 ln of the absolute value of 1 plus x squared plus c. This matches to e, and I'll take a moment to point out that they did not use the absolute value on 1 plus x squared, and you're allowed to do this only in the case where the expression cannot possibly be negative. So 1 plus x squared, since x squared has a domain of greater than or equal to 0, the whole expression then would be greater than or equal to 1, which is okay within the natural log domain. So for number 12, we actually have an improper integral. So I set up the improper integral, and I'm taking the limit as t goes to infinity and t replaced infinity as my upper limit of integration. Then I can integrate e to the negative x goes to negative e to the negative x. And evaluate that from 0 to t, I get negative e to the negative t minus a negative, so plus e to the negative 0. E to the 0 is just 1. What you need to see is that negative e to the negative t is really negative 1 over e to the t, and then plus 1 over e to the 0. When I plug in infinity into this t in the denominator, this first term goes to 0, and the second term just goes to 1, so my answer is 1.